Okay, hi guys, welcome to today's webinar. So today we just wanted to do AP review since we've gone through all of the topics that are going to be on the AP test. So is there anything specific that you guys want to go over today?
Can we go over searching and sorting? And on the AP test, is there going to be advanced like data structures and stuff like that, or that's not going to be on the AP test?
No, there's no advanced data structures on the AP test.
Okay.
I don't think there are any data structures at all other than arrays and array lists.
Yeah, those are the only.
Arrays, array lists, searching, sorting, right?
Mm-hmm.
Okay. Yep, I have to worry about those.
Okay.
Okay. Is there anything that you wanted to do, Prince?
You can just type in the chat.
Yeah.
Not really. No topic I'm still a little bit confused about. Array list. Okay. So I guess we can start with searching and sorting, and then if we still have time, we can go over array lists a little bit further. Is that good, guys?
Yeah.
Okay, so do you want like a basic overview of searching and sorting again, or do you want to do like problems?
Just a basic intro.
Okay.
Guess.
Should we open up the webinar doc
Yeah.
then, Asta, that we did?
Yeah, I think if we just show the animations for the searching and sorting and then give a brief overview, it should be fine. Because otherwise we have the video on searching and sorting already.
Okay.
Do you want to go through the animations then, Asta?
Okay, sounds good. I'm just pulling up the document right now.
Okay.
So for searching, there are only two come on, Google. Okay, there's only two searches that you need to know. So searching means that you want to find a value in an array or an array list. So I'm going to share my screen right now. So share. Okay, so this is going to be our, I guess like our little animation. So this is the array that we got, and we want to find a certain value in it. So what a linear search will do is it'll look at each element one by one, going in a linear fashion, and see, is this the number we want? If not, then we continue going. If it is the number we want, then the search is over. So let's say that we want to find this number right here, 412. If I do a linear search, we can see that what it's doing is that it's looking at each index. So let's skip back. And animation speed is slowed down. So if we do a linear search, it's going to look at each element at the index, see if that's equal to 417. And if it isn't, it's going to keep on going. So we can see that it's moving in a linear fashion because it's moving down the array.
Nice.
So if we increase the speed a little bit, it's going to keep on going until it finds 417. And when the value does match, it's basically, in this code, it's going to return the index. Because basically you want to find, usually in a searching algorithm, you want to find the location of an element in an array or an array list. So usually that's a value that you return. But sometimes they want to do some sort of processing with it. But that's the basic idea. So for a binary search, it's like the analogy of a dictionary. So like if you are trying to find the letter, if you're trying to find the word like queen in a dictionary, you don't start at A and then look at all the entries in A and then flip the page and then keep on going, because that's really inefficient. So what you do is like you open up your dictionary halfway through And then you're like, okay, is Q in between A to like, I don't know, M, or between M and Z? So you know that it's between M and Z, so you go to the latter half, and then you split that in half. And then you basically keep on splitting in half, seeing if your value is in the lower half or upper half until you find the value itself. So say we want to find 133 using a binary search. So slow this down and start this. So the binary search, what it's going to do is find the lowest element and the highest element in the array and find the middle value. So the middle value we have here is 533. So it's going to be like, okay, it's 133 less than 533. And since that's true, that means we're only going to look at this half of the array. We're going to completely ignore this because we know that like when we're going to, well, yeah. So keep on playing. I had a bit of word vomit there. So it's going to keep on doing this pattern again of now in the latter half, so this section right here, it's going to find the halfway point and be like, okay, is 133 less than or greater than 360? And since it's less than, now we're going to look at this half. So essentially, it's cutting down the amount we're searching, like the elements that we're searching through by half. Because first we started with this huge array of 31, and now we're only searching through 15 elements, and now we're only searching through 6 elements, and so on and so forth. The only stipulation with a binary search is that it absolutely must be in increasing order or decreasing order. So essentially, like the arrays has to be going in some sort of numerical order. If you have a random array that's unsorted, then it's not going to work because it's doing it based on the fact that this, like the lower half is going to be less than the higher half.
Oh.
So yep, that is searching. So for sorting, so the big idea is like, okay, we know that a binary search is way more efficient than a linear search. Yep. So how do we sort our array to make sure that it is in order? So there are 3 ways of doing that. There's a selection sort, insertion sort, and merge sort. So the selection sort basically looks at the first element and the next element and is like, okay, which one is bigger? And then it's just going to keep on swapping until you get the right order. So we have selection sort. We're going to have this on the slow side. And then we're going to hit random sort. Go. Oh, sorry. The selection sort, I apologize.
It's okay.
That was wrong. So what it does is it looks for the smallest element in the array and in the entire array, and then swaps it with the element in the first position. And then it's going to look for the second greatest element in the array, so from here on out, and then swap it with whatever was the second element, and so on and so forth. I got the order of the swapping wrong. So if we continue here, we see that it's comparing against all of the elements in the array to see which one is the smallest. And what's in red, 9, is keeping track of what's the current smallest. So now it's going to swap positions. So now 34 is like the second smallest, but now 32 is, and it's going to keep on going until it finds now the smallest element from 34 on, because we know that for certain that 9 goes where it is.
Wow.
And then it's going to keep on swapping. So I'm going to speed this up a little bit. So it's going to keep on doing this pattern of making the comparisons and then swapping accordingly. So if you do it fast, so it's just going to keep on swapping and searching through and then swapping. And then I guess one thing important to note is that like once 9 is sorted, it only searches through 14 through 41. It won't go through the entire array and look at 9 again. Similarly, for like when it's figuring out what to do with 36, it's only going to look from 36 on. it won't look through the entire array because we already know everything to the left of it is already sorted. So
Oh,
selection sort. Insertion sort is different. So this one is like, it kind of sorts everything relative to like the first element. So what the first thing it's going to do is like, okay, we're going to like set 3. Now it's going to look at 44 and be like, okay, is 44 less than 3? It is, so it stays in place. And then it's going to look at 38 and be like, okay, where does 38 go in this order here? It would go in between 3 and 44. So then it'll swap it. So it almost like, it forms like little arrays that become like bigger and bigger. You can think about it that way. And so it sorts everything relative to the smaller array. And then the array just keeps on expanding until you reach the end. It would be easier just to see it. So I will show that now. So random, sort, go. So we can see here, like what it first did is that it compared the first 2 elements. It set the first one as like sorted, and then it was like, okay, is 18 and 48, what is the order? And then it's like, okay, 18 goes before 48, and so it swaps it. So now we know that this is now established as sorted. So now we're gonna place 43 so that it still maintains its sorted nature. It goes in between 48. And so now we know that this whole thing is sorted. Now it's going to place 26 relative to all the other parts of the sorted array. So it's going to keep on continuing this pattern. Just speeding it up a little bit.
insert's a weird way of sorting, while select is a little bit more organized, like least to greatest, but it seemed like this is least to greatest as well, but it's just very different.
I mean, the idea is like it's similar to having like a hand of cards. Like,
Oh, it's like shuffling cards, right?
yeah, so it's like when you have a hand, you kind of look at the beginning. It's like your first, the first card you have in your hand, and then you place the second one relative to where the first one is. Then when you take your third card out, you put it relative to the other 2. That's basically the idea. And then you keep on sorting from there.
You can think of it like for insertion sort, you are going through the elements one by one and inserting it into its proper place in the list, versus with selection sort, you're already sort of starting with your sorted list and you're selecting elements from the unsorted list to go in order.
That makes sense.
Yep. So just speeding this up. Doo-doo-doo. So that's insertion sort. So merge sort is slightly messier, but it's still really interesting. So it's the only sort that AP is going to test you on that involves recursion.
Wow.
So essentially what it does is that it's going to break up this whole array into individual arrays where each element is going to be its own array of size 1. And then it's going to combine the 2 arrays together until and sort those like individual arrays, and then combine it, and then resort, and then combine it and resort until you essentially have a fully sorted array. So to illustrate what I mean.
So for this selection, does it have like a base case, or like no?
I think the base case would be that it's a size 1. So let's go back here.
Because when you said recursion, it has to have a base case in order for it to stop, where it's going to run on forever. Yeah.
Yeah, I mean, for searching and sorting, you will not need to ever write code for this on the AP exam. The only thing they're going to test you on is whether you can trace the code. And a big portion of tracing the code is understanding what the sort is supposed to do and recognizing it. So like, because this is recursion, if you see a method that like is merge helper or something like that, you know it's going to be a merge sort. So then you'll have a general idea of what a merge sort does. So we can see here with the different shades of the colors that these are supposed to represent individual arrays of size 1. So like this is a different shade than that, and then that, then that. So what it does now is going to look at like these 2 elements and be like, okay, let's sort them relative just to these 2, which is what it does.
That looks so weird. It's nothing like the insert, because the insert is more of like shuffling and like a revolving door.
Yeah, you could think about it that way. So what this particular algorithm is doing is that, so it sorted the first 2 elements here, then it sorted the second 2 elements, and now it's going to combine it, all 4 elements, and then sort those. And then put it into like the newly merged array, you could call it. So
What
now,
do you mean? Yeah.
so now it's gonna sort 2 elements, then these 2 elements, and combine them into one array of size 4. And then after all of that is done, well, we'll see. So now it's sorting them, replacing them back.
That's the same color. So if everything's the same color, it's like all one array, right?
Mm-hmm. That's what it's trying to illustrate.
Wow.
So now it's going to combine all of these into one array.
And that's going to be size. Wow, that's pretty big for an array.
Yeah, and I mean, it's going to still do the same thing for the other side. So I'm just going to speed this up a little bit.
Yeah.
So then it's going to do 2, then 4, combine, so on and so forth. Merge sort is one of the more confusing sorts, I would say, because it involves recursion. But the basic idea of it is that it's going to split the array into individual elements of size 1, and then it's going to combine them into 2s and sort them, then combine it into 4s and then sort them, and then just combine it. Keep on doing that until you're combining 2 halves into 1, and that'll be your sorted array. So this method, although it's much quicker than the other sorts, it is also very memory intensive because it's using so many arrays, and that takes up a lot of space in memory.
Like this just absorbs memory, but
Yeah.
It's the most efficient out of select and insert.
I mean, it's the fastest, but it's not necessarily the most efficient.
Yeah, sometimes the fastest is not the most efficient. So what would be like the most efficient, the selection or the insert?
It depends on the situation. Like depending on how the data is already ordered, some sorts are going to work faster than others. So like if the data is already like basically all in order, then selection and insertion are probably going to be faster than merge sort because they're just going to go through the whole array like once and they're going to see, oh, I only have to change 1 or 2 things, versus merge sort, you're still going to have to go and move everything down. So it kind of depends on the situation.
I see. So like everything was like out of place, and a merge sort would be like the best thing to do, right? If it wasn't sorted. And
most likely, yeah, right, Asta? Yeah.
I would say so.
If you have like a lot of order, you're definitely going to use the selection or the insert sort. Okay. Like for little things, right? But for like crazy things that's like looks catabolic, you're definitely going to use the merge sort.
Yeah, and also just one thing to keep in mind is like, so long as memory is not an issue, then
like,
you want to use
memory,
merge sort.
You can't use merge, yeah.
Because like if you have limited memory, exactly.
So how much memory do you need in order to run like the merge sort like at optimum level, or like how much memory should you have?
I don't know exactly, and that's not something that you need to know.
Yeah.
It's just like a concept that you should know that is something to consider.
Yeah.
But you
Oh,
don't
like-
know like the exact
Yeah.
amount of how much memory.
Yeah.
Hmm.
So I guess should we just do like maybe 2 or 3 practice problems and then move on to array lists?
Yeah. But I was starting to get it. It makes sense. It's like a different way of just organizing everything, point A to point B, least to greatest.
Mhm.
But they just have all the different algorithm or different system of doing it.
Mm-hmm.
Well, the first two look straightforward, while the third one is very like it's an unconventional way of getting point A to point B, but it still gets it done.
Mm-hmm.
Okay.
Should we
can
just
go
do ebook?
ebook? Yeah, sure.
So I can send the link on the chat.
Yeah. Should we just go through like the questions one by one, Asta, that are like on the document already?
Oh, yeah, we
Like
should do
start
those.
with binary and then so here.
Okay. Oh, yeah, whoops. Yeah, that's a good idea. We should do the searching too. So, send
I
this.
remember learning some of this last year, but it was like I didn't really understand it as much as a sophomore. It was for intro to computer science. But now since learning much more, so now it makes a lot of sense, or I can think about it like logically, like think about it, the concept.
Okay, so why doesn't everybody take a couple minutes to do the link the first link that Asta sent, and then we can go over it.
Okay.
So, so we want to go with the sorting one first?
Yeah.
So yeah, the medium multiple choice questions. So that'll be the first link that I sent.
Okay.
And just like comment when you guys are done.
Okay. I second guessed myself on the first question. I thought it was C, but it's actually A.
Well, we'll
when
go
I do
over it
that.
together.
Yeah.
So, Is everyone else done? Or ready to go over it at least?
Yep.
Okay, so cool. Let's go over the first one then. So let me pull up the link. I think I X'd out of it by accident. Okay, so the first question is asking us if that we want to find the iterations of the array if it's doing an insertion sort. So Nate, what did you mean by I didn't understand the searching? Like what an insertion sort is, or how the array works, or what?
It's the second question.
Okay. So what did everyone get for number 1 then?
For number 1, I got B.
Okay.
I got A.
Okay, so let's just look over this. So an insertion sort, remember, it like kind of sets the first element as sorted and then inserts everything relative to that. So let me share my screen. It'll make it easier to explain. So it's basically saying that 7 is set. Now we're going to place 3 relative to 7. So since 3 goes before 7, we know the first iteration of the array is going to be 3, 7, 8, 5, 2. It's going to maintain the order of everything next to it, but it's going to swap these so that it's in place. So automatically, we can get rid of B, D, and E. Shiraz, do you get why the answer is in B now?
Yeah.
So now what it's going to do is basically keep on doing this. So now it's going to sort 8 and place it in the proper spot relative to 3 and 7. So it's going to go just right after and stay in the correct place. So that's why A is correct as opposed to C, because C automatically places 5 in the right spot, but that's not how the insertion sort works. It's going to go element by element. So, okay. Hannah, do you want to take number 2? Oh, your mic is muted.
Oh, sorry. Okay. So this is one of the examples of one of the searching and sorting questions that you guys are going to have to trace through. So I'm going to go get my whiteboard to show you guys how to do this one. So, okay. Asa, do you mind keeping it on your screen? So I
Oh,
can see
sure.
how I'm doing it. Thanks.
Okay, 1 second. Doo-doo-doo. Okay.
Okay, thanks. All right. So this is asking what it's going to return. And so first we're just calling mystery of 0, 4, 3. So I just like to write that down. So I know what we're starting with. And so if you look at the mystery method, guys, do you notice something about it?
Yeah, it has 3 explicit parameters and has a lot of, yeah.
Oh, look at what it's actually doing, and then think about the different kind of searches. So is there like something specific that this method is doing
Is
that
it the binary search?
yep, good job. So basically you guys can see that this is looking for a middle point, and then each time, because since it's finding like the midpoint and then dividing it by 2, it's going to find every time it goes through this method where the midpoint is, and so that's going to tell you that it's a binary search. And so by identifying what type of search you're doing before you actually start tracing your code, that can sometimes help you to be faster because you kind of already know what you're expecting the code to do, like even without reading through line by line. So that's just like a good thing to take note of. So when we go into this method with 0, 4, and 3 as our parameters, so then we have an integer mid that's going to be low plus high divided by 2. So mid is going to be equal to 0 plus 4 divided by 2, which is 2. So, okay, then we're going to go to the first if statement, and we're going to see if low is greater than high, which it is not. So we're going to go to the next if statement, and we are seeing if array at the index of this middle point is less than num. And so, like we said, our middle point is 2. So we're going to look at the second index in the array. So that is 5. And so 5 is not less than 3. So we're going to move on to the next if statement. And this one is seeing if the middle point, which is 5, is greater than 3, which it is. So then we're going to go into that if statement, and we're going to return mystery of low, mid minus 1, and num. And so if you think back to what a binary search does, it basically, each time you go through it, it's finding the middle point, and then it's deciding whether to search for the upper half of the array or the lower half of the array. So that's what these if statements are doing. Since we found that the middle element was greater than num, then we're going to search through the lower half of the array. So we're going to return mystery of our low is still 0. But instead of our high, we're going to do mid minus 1, so that's 1. And then our number is 3. So now we're going to go back up to mystery again, and our mid this time is going to be equal to our low is 0 plus our high is 1 divided by 2. which is just 1/2, but with integer division, that's going to just give us 1. So then we're going to go into our if statements again. So if low is greater than high, but 0 is not greater than 1, so we're not going to go into that one.
I have a question.
Mhm.
Is 1/2, when it's going to be integer, is it 1 or 0?
Oh wait, Asta, it's 1, right? Integer division? Or
For-
no, is it 0?
Of 1/2,
Yeah.
it would be 0.
Oh, I'm sorry.
Because
Okay.
you chop off the decimal point. So 0.5 and take away the decimal is 0.
Okay, sorry about that, guys. So yeah, that's going to be 0. So then we're going to go into the next if statement, and we're going to see if the index 0 element of array is less than num. So at index 0, our element is 1. And our num is 3, so it is less than that. So we're going to return mystery of mid plus 1 is 1, and then high is 1, and our number is still 3. So then we're going to go back up to mystery again. And our midpoint is going to be low plus high divided by 2. So that's going to be mid equals 1 plus 1 divided by 2, which is going to be 1. So then we're going to go back into the if statements again. So low is not greater than high. And for the second one, we're looking at the element at the first index, which is 3. So if that is less than 3, it's not, it's the same. So then we're going to go into the next if statement. We're going to see if it's greater than 3, but it's not. So else we're going to return mid, which means that we have found the element. So basically this is just telling us that the element that we're searching for, which is 3, is found at the first index of the array. So that is why this method is going to return 1. C. Does that make sense to you guys?
No, I'm stuck.
Okay, what are you confused about exactly?
Just, I'm not sure. It's just the entire process of how to go through a binary search.
So basically what a binary search is doing is, so you have your array. Okay, so here, I'll draw it out visually what the code for this is actually doing. So, okay, so you have your array, right?
Yeah.
And so, basically low and high in this problem, are just telling you how big the array is, because low plus high, 0 plus 4, yeah, it's just giving you the size of the array. And then, so what you're doing is each time you go through it, this integer mid is going to give you the midpoint of the array. So when we go into mystery, you're finding mid to be, so this is your index, this is 1, 2, this is 3, and this is 4. So basically what mid is doing is it's telling you which element is in the middle of the array, so this one, because we're adding the index of the lowest element and the index of the highest element, and then dividing it by 2. And so that's how it's giving you the center of the array. So then basically what all of the if statements are doing is it's seeing if the element at the middle index is greater than or less than the element we're searching for. And we're searching for 3. So we're going to compare 3 to 5, and 3 is less than 5. So that tells us that we want to look at this half of the array, because we know that the element that we're searching for is less than the midpoint. So like now we have this 8 and this 9, we don't really care about that anymore. We only want to look at the first half of the array. So then we're going to do the exact same thing. We're going to take our lower half of the array, and we're finding the middle element. So that is going to be the element at index 1, which is 3. And then when we go through these if statements again to see if the element at this index is greater than or equal to the number that we're searching for, we find that it's not greater than or less than the element because it is the element we're searching for. So that's how you know when you get to that else that we have found the element that we're looking for. So then it's returning the index of it, which is 1.
That's starting to make sense.
Okay.
So I have
does
a
that
question.
Yep.
For this instance, low would be 1, while high would be 9, right?
So basically in this problem, low and high are always going to be the indexes of the lowest and the highest elements.
Oh, so it'd be like 0
That's how-
would be low, right?
Yeah, so that's how it knows what the midpoint is each time, because it's looking at the indexes, not the elements.
Oh, I'm looking at the number of the element. I'm not looking at the index. I have to look at the index to say low or high.
Yeah.
So if we wanted to say the highest index would be 4, right?
Yep.
Okay, cool.
Yeah. And so that's why we pass 0 and 4 into mystery the first time.
Nice.
Okay, does that make sense to everyone now?
Yep.
Okay. Okay, good. So next question. Do you want to go through the next one since it's on your screen, Asta?
Sure. So this is a selection sort. So just a reminder of what that does. What it's going to do is look for the lowest element in the entire array and swap that with the first element, and then do the same thing. Look for the second smallest, swap it, and so on and so forth. So what did you guys get as your answer for number 3?
For number 3, I got C.
C. Anyone else?
D.
Okay, D. So let's go through this. So the first thing it's going to do is try to find the smallest element in the entire array. So we know that's 2. So it's going to swap 2 with 10. So the array should read 2, 6, 3, 10, 8. So we know automatically, because of that, A and B are both knocked out. So now it's going to look from this part of the array on and find the next smallest element. So that's 3. So it's going to swap 3 with 6. So it would actually be easier to look here. So it's going to look from this point on. And we realize that 3 is the next smallest element. So it's going to swap 3 with 6. So now it should be 2, 3, 6, 10, 8, which both of them have. So let's keep on going. So now we're going to look from here on and see what's the smallest element. And it's 6. So the next iteration would be 2, 3, 6, 10, 8. So that's what makes it different from this. This one actually skips a step, because even if the element is in the right spot, it's still an iteration. So that's why D is correct. Does that make sense to everybody?
Yes.
Okay, cool. So I guess, Hannah, do you want to go over the last one?
Okay. So for this one, the correct answer is B. Did you guys get that, or did you guys get something else?
I got stuck. I didn't know how to answer that question.
I got C. Okay, yeah, this is a kind of tricky one to figure out. So basically the reason why it's B is you want the inner loop to start at the value of the outer loop plus 1, since you are comparing the element that you last found to the element below it, and then you want the loop to end at the very last element. So okay, for something like this where you might not exactly have a lot of time to go through the whole thing, because this can look very confusing at first. It's like a lot of code that you have to trace through, and you're trying to figure out not even just how to trace through it, but what is the right thing to go with it. It's good to just do process of elimination. So you want to sort elements in ascending order. Okay, what's a good way to explain this?
I mean, one way you could eliminate it is just like Hannah was saying earlier, that you want to search through all the elements. And since this is looking at 0 and going to element -1, that means this is not going to hit the last element. So you would want your inner loop to hit the last element. So you would want it to be less than or equal to element.length, which automatically knocks out 3 of the answer choices. That's how I thought about it personally. And then after that, like, not even, it's just like basic, I guess, analysis. So we don't want k to equal j, because that means we're kind of comparing the element against itself. And we want to compare like the 0th element with the first element. We want to compare something next to each other. And so that's why I went with j plus 1. Does that make sense to everybody? Just like how we, I guess, kind of logicked it through rather than having to trace it all out?
No.
Okay.
Yeah, this is kind of tricky one to explain.
Yeah.
Trying to think of like what else could make it clear to you guys.
Yeah, same. Well, did you understand why it should be k is less than element.length?
K is less than element.length.
For the second part of the for loop.
Yeah, for this part.
Oh, you're talking about the second one when it shows the if, like the inner for loop, right? No, I'm not sure.
Okay. So it's basically like, if you're trying to sort through an array, you want to hit all of the elements, right?
Yeah.
So with the outer for loop, it's actually not hitting the last element because it's j is less than element.length -1. So once it hits the last element, it's not going to evaluate it because of the way this loop is structured. And so that's why it's like, oh, you want the array to go through every element and sort every individual one. So that's why you want it to be k is less than element.length, because you want it to go through the entire array and sort through every element. Does that make sense?
Oh, yeah, because I see what you're saying. If the outer loop is not going to hit all the elements, because the whole point of sorting is just make sure all the data structures are like in order and everything's working well, right? So if your outer loop is out of place, you can't sort all the elements. So the data is going to be corrupted or out of order, I guess, or out of balance.
Yep. So that's why it automatically knocks out A, D, and E, because they don't have k is less than element.length. And so now the only difference between B and C is how k is initialized. And so if you're sorting through something, you make comparisons, right? So you don't look at the first element and compare it against the first element, because that doesn't make sense. You compare it against the next one. So you look at the 0th element and compare it to the first one. And these are a space of 1 apart. So you wouldn't want K to compare against J. You would want K to compare against J plus 1. Because you would want to take the first element and compare it against the second. Or the second element and compare it against the third. So does that make sense?
So I think what you're trying to say is you can't compare the first element to the first element. It just doesn't make any sense, right? Okay.
And then that's why it's J plus 1.
J plus 1.
Yeah.
Nice. So what happened if it was J minus 1? It would be like the same thing as the outer for loop?
If it was J minus 1, you'd probably have an index out of bounds error. Because that means,
you don't want that. Wow.
Yeah, because that means you want to try to find the negative first element. And that doesn't exist. So.
Wow.
Mm-hmm. Okay, is everybody good with this question?
Yes.
This is one of the trickier ones that you would see on searching and sorting.
Yeah, for sure.
Okay, so for the last question, this was kind of a trick question. What did you guys get for this one?
A trick question.
I first thought it was -1. Then I realized that -1 is not an integer, so it has to be won't compile.
Yeah, so the correct answer is E, that it won't compile, because if the method never goes into the for loop, then it's never returning anything. So an instance where that would happen is, let's say that your parameter A that you brought into this method was an array that didn't have any elements yet, then the length of the array would be 0. And so for this for loop to run, it's only going to go when I is less than a dot length. So if the length of the array was 0, then the for loop would never run. And so this method wouldn't be able to return anything. And therefore, the code is not going to compile. Does that make sense to everyone?
So it won't compile because it's not a main method there or present?
No, not because there's not a main method, because in the method declaration for this, we're saying that test is going to return an integer. And if you never go through the for loop, then we're not going to, we don't have a return statement for when this doesn't go through the for loop. So it's not returning an integer. And so that goes against the rule that you're declaring that this is going to return an integer, and then you're not returning an integer. So it won't compile.
Oh.
Does that make
What
sense?
is like 1, 2, 3, 4 then? Isn't it the parameter for the integer?
So the 1, 2, 3, 4 is the array A that you're passing in, so it's the first parameter. But so even though if you were to do this method, and like technically that is valid, like that has 4 elements, so that for loop would run. Java is going to recognize when it's compiling this code that if the user was to input an array that didn't have any elements, then it wouldn't go into this for loop and it would never run.
Wait, doesn't it have like 4 elements?
Yes, but basically you're passing in this parameter A at runtime. So the program, it compiles before you actually run it. And so Java is going to recognize when it compiles the program that it's possible that a parameter could be passed into this method that makes it so the for loop's not going to run, and so it doesn't return anything.
Okay.
Does that make sense?
Yes.
Yeah.
Okay.
Yeah, so it's essentially that even like pretending this whole section doesn't exist, Java won't let you write this method at all. It'll say that it has an error. And just like Hannah said, it's because if it's an array of length 0, it just won't return anything. And this method needs a return of a type integer.
Wow.
Yep, so this one is like, I definitely agree with Hannah. It's a bit of a trick question.
Yeah, you probably won't get a question like that on the AP test, but
Yeah, I know I didn't. So,
yeah. I, feel
I
like
was so confused. I'm like,
you like
it didn't
that.
have a main method, so I'm like, there's no way it should compile since it doesn't have a main method. But it's like my logic was wrong. So
Yeah, it's not necessarily that it doesn't have a main method, because a lot of the times on the AP test, like obviously you have a limited amount of time, and so it's not going to be able to show you code for a whole program. Instead, it's going to show you methods or bits of code
mhm.
that are going to test you on specific topics. So this is okay that it's not showing you the main method, because it's still telling you what is technically passed into the method. So don't worry about that if it doesn't have a main method, if that's not the topic that the question is testing.
Mhm.
okay.
Okay, so I think that is it for today. Thanks guys for coming.
Yeah.
And I think that the rest of our webinars are just going to be going through
Review,
you guys'
right?
questions like this. So
Yeah.
make sure to keep coming with questions or problems that you guys have.
Yeah.
And sign up always for one-on-one tutoring if you have any other questions.
Okay. And the test is May 2nd, right? Because it's starting to get like very close. And the last couple of weeks, I haven't really did any Java, so I got really like study, and just
Mm-hmm.
yeah.
Yeah, I'm not sure what the exact date is, but May 2nd sounds correct.
Yeah.
Yeah, it's definitely like the first 2 days of May. Yeah, and then AP testing is right around the door for everybody in part.
Fun stuff.
Yeah.
All right, well, I know you guys will do well because you guys are working hard.
Yep.
Yeah.
All right, well, we'll see you guys next time. Bye.
Okay.